Next question number 51. The energy of single Eg orbital in tetrahedral complex will be. In tetrahedral complex, the splitting is reversely taken. Suppose you take 5 d orbitals. How is splitting in tetrahedral geometry? Look here, higher energy level is what? Eg. V represented by E. So, higher energy level in tetrahedral geometry, it will be higher energy level T2Z. This is what T2, and lower energy level, this is what EG or E set of orbitals, tetrahedral geometry. But question is that EG orbitals, what is the energy? This is what actually the energy difference between these two, we consider what delta T or 10 dq. This is coming to be minus 0.6 delta T, we say. This is what plus 0.4 delta T, we say. That is, question is that what is the energy of each Eg orbital in the tetrahedral geometry? The Eg will be what? 0.6. 0.6 means what? Minus 3. Minus 3 by 5. Minus 3 by 5 is the answer. So, A, option A is what? Minus 3 by 5 delta T. B is 3 by 5 delta T. And C is minus 2 by 5 delta T. D is 2 by 5 delta T. Actually, how to get minus 0.6? So, here answer is E for question number 51. One of the ligands present in G salt. You should know what is the actual G salt formula. Let me write the G salt formula so that you can easily understand what is the ligand present in G salt. The G salt formula is Pt, Cl3, C2H4, C2H4, this is what minus 2, minus 2. So, platinum should be plus 2, it should be what K. Then PtCl3 C2H4 minus the platinum oxidation number plus 2. See, one is chloride ligand, the other one is what ethylene, simply C2H4. So, A is given as what carbonyl, B is given as what CO, and C is given as what amine, and D is given as what ethylene. So, ethylene is the one of the ligand present in this particular G salt. Then answer is what D. Let's come into question number 53. Question number 53. Select the species that exhibit both 4 and 6 coordination numbers. Notice some of the metal ions specially exhibiting only coordination number 4 or 6. But some of the metal ions exhibit coordination number 4 and also coordination number 6. Then when you talk about beryllium plus 2, option A is given as beryllium plus 2. Beryllium plus 2 always exhibiting coordination number 4, never be more or never be less in the case of beryllium plus 2. B, chromium plus 2 also always exhibiting coordination number 4 only generally. And option C, nickel plus 2. Nickel plus 2 exhibiting this coordination number 4 and coordination number 6. See, suppose you talk about nickel Cl4 minus 2C. In this nickel plus 2, but coordination number is 4. So, many times you are written one more complex, take NiNH3 taken 6, NH3 taken 6, this is also plus 2. In both of these complexes, nickel is plus 2, but here coordination number 4, here coordination number 6. The best option among the ABCD is, now see the correct answer here, nickel in plus 2 oxidation state exhibit coordination number 4 and also 6. So, answer is C. Which of the following data is not employed in the detection of complex formation? Suppose the metal and ligand is mixed together, metal plus ligand. Then you got a complex, take Ml complex. Let me write here n number, I will write n number of ligand. Then you got it, Ml complex. How can you say that this complex has been formed? By what difference? By what data? By what parameter? We can understand metal and ligand reacting together, giving rise to a complex. First, he has given what A option is what? pH difference, and B optical density, and C ionization energy, and D molar conductivity. Which one of the following data are not employed? Not employed. Which of the following is not helping us to know a complex has been formed? Yes, once metal is converting into what complex, there will be a change in the pH. There will be a change in the pH that can be identified by the change in pH. And B optical density. Optical density, once you are passing light through the solution, suppose whenever a complexation is taken place, a complex is formed, there will be change in the color. The color of the solution may become light or dark. Based on that also you can understand a complex has been formed. So optical density may change. So it may be light in color, it may be dark in color. According to that also you can understand a complex has been formed. Coming to ionization energy. Suppose metal, here the certain X metal is there, X metal is forming the complex. Once in the free metallic state, only the complex, but metal is remaining same. Therefore, there will not be any change in the ionization energy. So, on either side, metal is remaining same. How can it will be? It's the ionization energy will be changing? No, the change will not be observed only in the ionization energy. Therefore, the 54th answer is what? C. But you talk about the molar conductivity. See, metal and ligand, and whenever the complex is formed, there will be change in the molar conductivity. The conductivity may decrease or may increase. Therefore, option A, pH change will be there, optical density will be changed, and molar conductivity also there will be change. But only ionization energy, metal remaining on either side same. Therefore, its IP value is not changing. Therefore, answer is what? C. Select the metal ion that forms always 4 coordinated complex. 4 coordinated complexes. Now, coming to option A, cobalt plus 3. See, cobalt plus 3 generally forms complex with coordinate number 6 only. Coming to option B, Mn plus 2. Mn plus 2 forms coordinate number 4 and also coordinate number 6. There is both possibilities. A D block metal ion in plus 2 oxygen state generally forms coordinate number 4 complexes, coordinate number 6 complexes. Then coming to C, chromium plus 3 is said. Chromium plus 3 also always forms a complex with the coordinate number 6 only. Coming to beryllium plus 2, recollect again, beryllium plus 2 belongs to S block and secondary group. It is very smaller in size. Be plus 2 is very small. It can accommodate hardly 4 ligands only around it. Therefore, here the 55, question number 55, answer comes to only beryllium plus 2. So, answer is what? D. Question number 56, which of the following ligands is not expected to participate in complexation? Generally, in complexation means within the coordinate purity, within the bracket, what are the ligands generally we see? A is what? Thiocyanato. Yes, many times we see thiocyanato complex are there. Coming to B, thiosulfate. Thiosulfate is also capable of forming different types of complexes. We see Rm and silver complexes. Coming to C, nitrate. Yes, nitrate is there inside and outside the coordinate sphere. Yes, we can expect that one. Generally, perchlorate ion generally we never see within the coordinate sphere. Often we see outside the coordinate sphere, but we never see inside the coordinate sphere as acting as what? Ligand. So, 56th answer is the D. Coming to question number 57. 57. Select the species that has charges, 6 charges and behaves as 4 particle system. 6 charges you have to get and 4 particles. 4 particles and 6 charges. Now you take option A, COEN taken thrice Cl2. Outside the coordinate sphere, 2 chloride ions are there. 2 and 1 complex. You are getting only 3 particles. Coming to option B, Na3Fe(C2O4) taken thrice. That I am writing option B. I am writing, you see, Na3 Fe C2O4 taken thrice. This is the complex, option B. Once you are putting this particular in water, take aqueous solvent. How it deionizes? Look here. It is Na plus plus 1 complex you are getting C2O4 taken thrice. O4 taken thrice it will be what? Minus 3. So, for the question, select the species that has 6 charges and behaves as 4 particle system. Clearly, we are looking 3 plus 1, 4 particles, 3 plus 1, 4 particles, and charges 3 and 3 charges, 3 and 3 charges, 6 charges. So, option B the correct answer here. So, here question number 57, answer is B. Question number 58. Question number 58. The white precipitate Hg2Cl2 turns black on treating with ammonia. The formula of the black compound is. You will see the semi-micro analysis, we will get this particular. It is also useful in complexation. Now, whenever mercury chloride treated with ammonia or ammonium hydroxide, a precipitate we are getting what? Black precipitate. Mercury chloride on treating with ammonia. Mercuric chloride on treating with ammonia or ammonium hydroxide, then we are getting a black precipitate NH2 HgCl plus Hg. This is the black precipitate you are getting. So, come to the options. A. NH4 HgCl2, no. Option B. NH2 HgCl4, no. And C. NH2 HgCl, C. NH2 HgCl plus Hg. Then fourth option, Hg NH2 taken 4 Cl2. So, this is the, whenever mercury chloride reacts with ammonia, then you are getting a black precipitate. The composition of the black precipitate is this one. So, here the answer is C. Coming to question number 59. Which one of the following will show ionization isomerism? See, we have discussed isomerism. Under that ionization isomerism, there should be anionic exchange, anionic ligands exchange, then only ionization isomerism is possible. Coming to option A, inside NY is plus and SO4 minus. So, inside is positive ligand, outside is what? Negative ligand, that will not exhibit. Coming to option B, PT NS3 taken for Cl2Br2. PT NS3 taken 4 times Cl2 and Br2. So, inside and outside different types of ionic ligands are there. By the exchange of ligands in between the coordination sphere, it can exhibit the isomerism. So, here for question number 59, the B the answer here, because this only can exhibit this ionization isomerism. Question number 60. Which one of the following will show geometrical isomerism? Option A, COEN taken thrice. Actually, this is symmetric bidentate. If symmetric bidentate ligand is there, that never exhibits any geometrical isomerism. Coming to option B, FeC2O4 taken thrice. Yes, this is also auxiliary ligand, actually symmetric bidentate, ovo donor. Then this cannot exhibit again geometrical isomerism. Coming to C, and nickel tetrachloride, it is actually sp3 and tetrahedral geometries. Yes, we know tetrahedral geometries never exhibit any geometrical isomerism. Moreover, all the ligands are same here. Coming to option D, CONS taken 4 times, 4 times Cl2 plus. This can exhibit cis centrons by changing the position of chloride ligands. A4 B2 type can exhibit geometrical isomerism. Therefore, answer is D. Question number 61. Choose the geometry of the complex that does not exhibit geometrical isomerism. Which geometry cannot exhibit geometrical isomerism? Coming to A. Octal geometry, yes, octal geometry exhibits geometrical isomerism. Cis centrons possible with this octal geometry. Coming to scale planar, thoroughly discussed. Scale planar geometries exhibit this geometrical isomerism. Cistons you can write. And option C, tetrahedral. Yes, remember tetrahedral geometries cannot exhibit geometrical isomerism, as that particular geometry is not planar, and therefore that cannot exhibit this geometrical isomerism. So here question number 61, answer is C. Question number 62. The complex CO taken 4 times Cl to show. See again this particular is A4B2 type. A4B2 type. And moreover these are all monodentate ligands. What is given? CO NH3 taken 4 times Cl2 plus this Ma4B2 type, all are monodentate ligands. This particular complex then only geometrical isomerism and only optical isomerism, see both, and polymer isomerism. This particular complex Ma4B2 can only exhibit geometrical isomerism. We can write cis and transfer that, but not any other isomerism is possible. Therefore, answer is A. Question number 63. Question number 63. The complex Cr C2O4 taken thrice show. This is again what a bidentate ligand is there in the complex. This is MAA taken thrice type. MAA taken thrice type plus or minus N. This particular complex can exhibit only optical isomerism. Then oxalate acts as what a tridentate ligand. No, the oxidation state of chromium is +6 is said. Next, optical isomerism is possible, geometrical isomerism is possible. In this, geometrical isomerism is not possible, and in this particular oxalato complex, only oxidation number is +3. He said tridentate is saying that is not correct. +6 oxidation number, no, only +3 oxidation number. Optical isomerism is possible, geometrical isomerism is possible. In this, geometrical isomerism is not possible, only optical isomerism is possible. Therefore, question number 63, answer is C. Coming to question number 64, FeS4 solution gives brown color ring in testing nitrates or nitrites. This is due to formation of the complex. Then you have to check the brown ring complex, you have to see. What is the actual formula of brown ring complex? One should remember, it's very, very important. Brown ring complex formula, Fe, H2O taken 5 times, NO and SO4. This is the complex. Moreover, NO inside is what? Nitrosonium, and Fe always exhibiting Ar +1 oxygen state. Wherever this particular complex is there, then that will be a brown ring complex. Check our answers now. A. Fe H2O taken 5 times NO +2. So this is the correct answer. This is the correct answer. So answer is A. Coming to question number 65. Question number 65. The most stable ion is means you have to see in which complex the ligand is strong field ligand. Let us check it. According to that one, a strong field ligand generally produce a highly stable complex, stable ion. Therefore, option A is FeOH taken thrice, simply as in ferric hydroxide. That is also not correct. And option B, FeCl6 - 3, and option C, FeCN taken 6 minus. FeCl6 is there, FeCN6 is there, and both are having what? Oxidation number same. And Cl is what? Weak field ligand, and cyano is what? A strong field ligand. And therefore, cyano complex should be more stable. Therefore, here answer C the correct answer. Answer C correct for question number 65. Coming to question number 66. Question number 66. The question is very big. Read it. 1 mole of complex compound CONH3 taken 5 times Cl3 gives 3 mole of ions on dissolution in water. First statement. 1 mole of the same complex reacts with 2 moles of AgCl solution to yield 2 moles of AgCl. The structure of the complex is. First, to take the complex, what is given? CO NH3 taken 5 times Cl3. This is the complex given. It gives 3 moles of ions, is saying 3 moles of ions in dissolution in water. 3 moles of ions means 2 chlorides should be outside. The actual formula of the complex, what we can write? 3 moles is saying CONH3 taken 5 times, keep 1 Cl inside and 2 chloride outside. 3 moles, 2 and 1, 3 moles of ions you are getting. Next, 1 mole of the same complex reacts with 2 moles of AgCl. Here for the 2 precipitate, 2 chlorides are there. Once you are putting AgNO3 into this, then you are getting what? 2 moles of AgCl. 2 moles of AgCl. This is the information given for the complex. Let us check the options now. A. CO2NH3 taken thrice, Cl3,2NH3. NH3 should not be outside. Coming to B. CO2NH3 taken 4 times, Cl2, ClNH3. ClNH3, how can it be outside? No. Coming to C. CO2NH3 taken 4 times, Cl2NH3. That is also not correct. So, according to our solving of this particular question, answer to the question, this is the correct formula and this is the correct answer. Therefore, option D is the correct answer, which is carrying 2 chlorides outside, giving 2 moles of AgCl as the precipitate. So, here answer is what? D. Coming to question number 67. 67. In the coordination compound K4NaCN taken 4 times, the oxidation state of nickel is. Oxidation state of nickel is C. K4 Ni CN taken 4. See, inside -4, outside +4. -4 is actually getting cancelled by +4. 4 cations, 4 anions, then nickel should become what? 0. In this particular complex, nickel is 0. What are the options? A is 0, B is +1, C is +2, D is -1. So, answer 0 oxidation number for nickel. So, answer is A. Coming to question number 68. 68. The correct order of magnetic moments of spin-only values we have to consider among given. What are actually given? Check the 3 complexes: MnCl4 -2, COCl4 -2, and FeCN taken 6 -4. First, we write the 3 complexes. What is given? MnCl4 -2. Second one, COCl4 -2. Next, third one, FeCN taken 6 -4. -4. These are the form. See here, Mn is what you know, it is what? 25. 25 means what? D5 has 2. Then +2 means D5. D5 means it is having what? 5 unpaired electrons. Its magnetic moment coming to be 5.9 bm. First one is 5.9. Coming to cobalt, it is what? 27. 27 means what? D7s2 +2 oxidation number, remaining D7. D7 means how many unpaired electrons? 3. It is coming to be what? 3 point, the magnetic moment coming to be 3.87, we take 3.87 bm. Coming to this one, Fe, it is what? 26. It is what? D6s2, iron oxidation number coming to be +2. +2 means what? D6 remaining. Moreover, this particular CN is what? Strong field ligand. All the electrons are getting paid. No unpaired electron, the magnetic moment coming to be 0. This 5.9, 3.87, 0. So, this is more than this, this is more than this. This is order of magnetic moment. Therefore, question number 68, answer is A. Question number 69. The oxidation state of chromium in the complex CrNH3 taken 4 times Cl2 plus. See, CrNH3 taken 4 times Cl2 plus. See, 2 chlorides inside, 2 minus charges, 1 more plus charge is there. Then total oxidation number of this particular complex of chromium coming to be +3. So, for this particular complex, or for question number 69, answer is A. Question number 70. The IUPAC name of the coordination compound K3FeCN taken 6 is. What is the complex given? The complex given is K3FeCN taken 6. This is the. What is the name of this particular complex? Simply potassium, hexacyano, cation and anion. So, we have to add 8. Therefore, potassium, hexacyano, ferrate 3. So, here potassium, hexacyano, ferrate 3. So, option B potassium, hexacyano, ferrate 3. The correct answer for this answer is B. Next, coming to question number 71. 71. Which of the following cyano complexes would exhibit least value of paramagnetic behavior? Least value of paramagnetic behavior. Now let us take option E. Cr Cn taken 6 minus 3. Cr taken 6 minus 3 is given. Chromium minus 3 means chromium is what? Plus 3. Chromium plus 3, that is what? Cyano complex. That is cyano complex. Then chromium plus 3 means it is what? D3. D3 means 3 unpaired electrons. First one. Option B. MnCn taken 6 minus 3. Mn minus 3 means Mn again here plus 3. Mn plus 3 means what is remaining? D4. D4 this strong field, therefore 2 unpaired electrons in this. 2 unpaired. First one 3 unpaired electrons, second one 2 unpaired electrons. Next, FeCn taken 6 minus 3. FeCn taken 6 minus 3. Option 3 Fe plus 3. D5. Cyanide is what? Strong field. Strong field means what? Electrons are getting paid. 1 unpaired electron. First one 3 unpaired electrons, second one 2 unpaired electrons, third one 1 unpaired electron. Coming to the fourth one, see what? CO, Cn taken 6 minus 3. Then here is what? Cobalt plus 3 and it is what? D6, but cyanide is what? Strong field ligand. Then electrons are getting paid 0. No unpaired electron here. In this 3 unpaired, 2 unpaired, 1 unpaired. All the 3 are exhibiting certain magnetic moment. This is highest, then second one, third one. But in this particular complex, that is what? No unpaired electron. It is not exhibiting. What is question? Which of the following cyano complexes would exhibit the lowest, he said, lowest magnetic moment? This is no magnetic moment. So answer is what? D. Question number 72. Nickel Z equal 28 combines with a uninegative monodentate ligand X to form a paramagnetic complex nickel X4 minus 2. The number of unpaired electrons in the nickel and the geometry of the complex ion respectively. A monodentate ligand is said and X. Nickel is forming a complex, nickel X4 is said. Nickel X4 minus 2 is saying. And the geometry of the complex ion or respectively. Ion or respectively. So suppose you take combines the uninegative monodentate ligand X. X is given, X means you take a halide ligand, you take it may be chloride ligand. Then you can take this particular as nickel tetrachloride, nickel tetrachloride minus 2. Yes, nickel with coordinate number 4 and halide ligand you take, then its must and should be sp3 hybridization and tetrahedral geometry. Once sp3 and tetrahedral, nickel in this water, nickel plus 2 and with d8. d8 means 2 unpaired electrons and geometry coming to be what? Tetrahedral. Let us see the options. 1 tetrahedral. Tetrahedral we agree, but number of unpaired electrons are 2. Option A is not correct. Coming to the B. 2 tetrahedral. Yes, 2 unpaired electrons are there. Geometry is what? Tetrahedral. So answer is B. Coming to question number 73. Question number 73. Which of the following has square planar geometry? Square planar. Check it now. COCl4 minus 2. COCl4 minus Cl is what? Weak field ligand. And definitely it is must and should be what? Tetrahedral geometry only, not square planar. Coming to B. FeCl4 minus 2. Yes, Cl is again weak field. Then it will be definitely a tetrahedral geometry. Coming to C. Nickel tetrachloride. Well known to you, nickel tetrachloride is sp3 and tetrahedral. Coming to PtCl4 minus 2. PtCl4 minus 2. PtCl4 minus 2. Yes, we agree it is weak field ligand, but wherever 4D element or 5D element, 4D element or 5D element forming either octahedral complex or tetrahedral complex, always that is inner orbital complex only. Always inner orbital complex, 4D and 5D irrespective of the nature of the ligands, either strong field or weak field, always forming inner orbital complexes, Therefore, D only found to be non-orbital complex, that is square planar geometry. So, question number 73, answer is D. Question number 74. The coordination number and oxidation state of element E in the complex EN taken by C2O4 NO2, where En is ethylene diamine or respectively. Where En is ethylene diamine or respectively. E actually C2A element E is said, is E, we agree. Then En taken twice and C2O4. But they still, the anion is given as what? NO2. Now we talk about these particular two ligands. En is what? Bidentate. How many times? Twice. Therefore, bidentate 2 times it is there. Therefore, it is actually capable of forming 4 bonds around the metal. And oxalate again bidentate, it is capable of forming only 2 bonds. Therefore, total chemical bonds around the metal ion coming to be 6. Therefore, here what is given? Where En is what? Coordination number and oxidation state of the metal is. This is what? -2. This is neutral. This is -2 and one more -1 is there. So, oxidation number coming to be +3 and the coordination number coming to be 6. Therefore, option D the answer, 6 coordination number and oxidation number +3. 6 coordination number and oxidation number coming to be +3. So, these are the answers. Therefore, here answer is what? D. Question number 75, which of the following is an optical isomer? Coming to the option A, CO and ST taken thrice Cl. This is what actually 3 ligands are one type, 1 ligand is the other type. No, it cannot exhibit. Coming to B, CO, En, and ST taken 4 times +2. 4 ligands, monodentate ligands are there? No. Coming to C, B and C are actually both are one and same. There NST taken 4, here aqua taken 4. Next coming to D, CO, En taken twice, NST taken twice. This can exhibit this optical isomerism. Therefore, question number 75, answer is D. 76. Question number 76. The magnetic moment of nickel tetrachloride -2 is. See, recollect many times we discussed this particular nickel tetrachloride. Many times this question is repeated in different entrance exams. See, -2. Yes, nickel is 28 we know, D8S2. In this, nickel is +2, D8. It is D8, moreover chloride is what? Weak field. Therefore, electrons are not getting paid here. Then D8 electronic configuration, 2 unpaired electrons are there. Check the answers. Option A is given as what? 2.82 bm. 2 unpaired electrons, 2.82 is the magnetic moment. So, for question number 78, answer is A.